Unit 5, Part 1. Unit 5 is really the climax of the first part of the course, as I've said before. First part of the course goes up to the end of Unit 6. Then you have your first exam, the first of 3 exams you absolutely necessarily have to take. Unit 5 is where we bring everything we've learnt together, and it's where it's on the truth table tests for an argument's validity, and it's here where we bring everything we've learnt together and are able for the first time to show for a valid argument form that it is valid. That is, we're able to show that so if you remember back to Unit 1, we learned that an argument is valid if and only if its form is valid. Its form is valid if and only if it has no counterexamples, that is, substitution instances with true premises and a false conclusion. We could present a counterexample to an invalid argument form right away. Right? We could abstract a form for given a particular argument, we could abstract its form, and if we could find a substitution instance for that form, where the premises came out true and the conclusion false, we could say, there is your counterexample. One counterexample proves that this argument form is invalid, and thus any particular argument which takes this argument form, or which has this argument form, is invalid. But we weren't yet able to, and not until now, not until this chapter, what we learn in this chapter, we will be able to show of an argument form that has no counterexamples that it has no counterexamples, that it's not possible for it to have any counterexamples. Right? We needed to build up our system of sentential logic. We needed to learn the concept of truth functionality, especially, and we needed to construct our system of truth functional sentential operators in order to be able to do what we're going to do in this truth table test of an argument's validity and prove that an argument form is itself valid. Much of your exam will be, you'll be presented with questions and questions that ask you to use the full truth table method to prove of some particular argument form that the argument form is valid. That is, many of the questions in the exam, some of the questions in your exam with the most amount of points allocated, will be very much like the questions in the exercises, especially like unit question 1 in the exercises. I've got the first one up on the board, so that's page 92, exercise 1. Right, you'll be presented with questions like this, right, where you're presented with a couple of premises and a conclusion listed as so, and you'll be asked to use the full truth table method to determine whether it is valid or not. Okay, so I'm going to do one of them for you. Well, I'm going to do a couple, but I'll start by doing 1B, and as I talk about this, as I explain what I'm doing while I'm answering this question, I'll be running through much of the content, much of the material of the chapter and what's being taught in the actual thing. But let me start by reading for you the opening 2 paragraphs of Unit 5 on page 74, where Klenk really brings together, explains how everything we've been doing has been leading up to this moment, and how all the knowledge we've learned is brought together in this chapter. So this is page 74, beginning of this Unit 5. In Unit 1, it was emphasized that the validity of arguments is a matter of their form rather than of their content. In Units 2 and 3, you learned the structure of sentential logic and the rules for computing the truth values of compound propositions. In Unit 4, you learned how to analyze the structure of English sentences and to symbolize them and to represent their form by means of our logical language. In this unit, you will finally put it all together and learn how it is possible in sentential logic to test argument forms and hence arguments for validity. Remember that an argument is valid if and only if its form is valid, and an argument form is valid if and only if it has no counterexample, no instance in which all the premises are true, but the conclusion is false. To test an argument form for validity, then, we need to examine its instances to see whether there are among them any bad cases, any counterexamples. What you will be learning in this unit is the truth table method. which is simply a way of setting out all the possible instances of the form. That is, all possible combinations of truth values for the simple component sentences, and then computing the results of these possible instances. Once we have constructed our list of possibilities and computed the results, all we need to do is look them over to see whether there are any instances with true premises and a false conclusion. If there are, the form is valid. If there are, the form is invalid. If not, it is valid. Okay. The stress there is on this part, on the all in the word, in the sentence. What you will be learning in this unit is the truth table method, which is simply a way of setting out all the possible instances of the form, right? So the theoretical question, which we can now answer for the first time, is how is it possible for us to capture, to get a handle on all the possible counterexamples? Because think of what an argument form is. It has an infinite number of substitution instances, right? How is it possible for me to bring into view that infinite number of substitution instances of a form and say of that infinite set of substitution instances that none of them are counterexamples, that none of them are such that the premises come out true and the conclusion false? Okay, so answering that question, if you have the answer to that question, you'll have the grasp of the importance of the base columns of the truth table. Okay, so section 1 of the chapter is constructing base columns for truth tables, right? So I'll explain what they are, but it's because the base columns contain everything that matters for determining the truth value of the premises and conclusion, that it's because of that we're able to bring the infinite number of substitution instances for an argument form into view and say none of these substitution instances are counterexamples, right? So just reading you from 75, Introduction to Section 1, constructing base columns for truth tables. According to our definition, a valid argument form is one in which there is no possible substitution instance with true premises and a false conclusion. To test argument forms for validity, then, we must be able to determine whether or not there is such an instance. Since there are an infinite number of substitution instances for each form, we cannot possibly inspect each actual instance, each meaningful argument of that form, but we can do something which serves our logical purposes just as well. Write down all the possible combinations of truth values for the variables. Such a list is the base columns. Okay, so let me run through an example for you. All right, I'll start it in the next section, but what it's going to be is, this is exercise 1B, right? You're just given, as I showed, the list, the argument where it's got the premises and conclusions, so you're not given this in part of the question. It looks like how I showed you on page 92, right? I'm making a point of this because your exam will present you with something like this, right? It's 1B, right? It'll present you with a couple of premises and a conclusion like that. What you do is list each statement form. Remember, we're testing argument forms. An argument form is a set of statement forms, right, or sentence forms, where you've got separated into premises and conclusion. So one or more statement forms is premises. Here we've got two: premise 1, premise 2, and a conclusion. A statement form that is a conclusion, right? Statement forms. Okay, so. All right, so you list them 1, 2, 3. So these are the first things that appear. You list them horizontally across like this: premise 1, premise 2, premise 3. And then what you do is you construct the base columns, right? You count how many sentential variables appear, right? So you say, okay, I've got the sentential variables are the P, Q, R, ST if there's more. But usually it's only 2 or 3. In most questions it'll be 2, P and Q, or 3, P, Q, R, right? So here we've got P, and we keep going, we've got Q. Here we've still got, this is only P, and here Q. So we've only got 2, okay? You construct base columns, that is, you list You move to the left and you list alphabetically all the potential variables. Here we've just got P, and then we've got Q. And then we start at the right, and start at the rightmost one, and we go true, false, and then we move to the left and double, true, true, false, false. Okay, that's what we do. All right, I'll come back in part 2 and explain how, explain the theoretical import of the base columns. Right? They're important because they contain all the information that could possibly go into determining the truth value of each of these statement forms.